Hello, my name is Hugh Rorty from Rutgers University. Thank you for taking the time to hear my story on the sargassum research we are conducting around Puerto Rico and the Virgin Islands. I would like to acknowledge my co-authors on this work, Mr. Joe Anarumo from Rutgers and Miguel Canals and Haibu Shu from the University of Puerto Rico at Mayagüez. We operate under our respective IEEE Regional Observing Systems, MARICOOS for the Mid-Atlantic and CARICOOS for the U.S. Caribbean. This work is being sponsored under a cooperative agreement with the NOAA Integrated Ocean Observing System. So I would like to present an outline for my presentation. First, I would like to introduce you to the sargassum problem that has been impacting the Caribbean for the past decade. Next, I would like to describe the modeling tool that we have developed to forecast the movement of surface waters around Puerto Rico and the Virgin Islands. Next, how we are evaluating new products for this forecast tool, which include surface currents from the finite volume coastal ocean model, better known as FVCOM, and sargassum concentrations from the maximum chlorophyll index from NOAA. Lastly, I'd like to discuss a sargassum beaching event that took place on May 3rd of this year and the trackers tool's ability to predict the beaching event. So first, the description of the sargassum seaweed problem in the Caribbean. Starting in 2011, floating sargassum began to impact coastal communities around the Atlantic. Here is a time series from 2011 to 2018 documenting the growth of sargassum in the Caribbean. Thousands of tons of sargassum end up on beaches in the Caribbean and the Americas. Mounds of algae on beaches and dense mats in the ocean harm marine ecosystems and disrupt recreation and fishing. Removal and containment efforts are often expensive and put marine life at risk. Here are two recent news stories concerning sargassum. One noting the end of the sargassum season off Cancun, Mexico, and the other on the impacts of sargassum on St. Croix beaches from just this past month. So now I'd like to describe the tracking tool that we developed for this problem. Since August of 2019, we were provided forecasts of surface trajectories for 7 locations around Puerto Rico and the Virgin Islands, which we term the sargassum tracker. In February of this year, we added an 8th region along the northeast coast based on input from users. In August of this year, we began coloring the virtual drifters by the most recent alternative floating algae index concentration. This is a product from the University of South Florida, which has been used as a marker for sargassum. In March of this year, we started performing a daily validation of the model's surface trajectories and currents using the hourly surface currents from the CARICOOS high-frequency radar network shown here. So here we have an animation of surface trajectories from HFR and AMSEAS. So on the left is a simulation of surface trajectories using the measured surface currents from the high-frequency radar network. And on the right is a simulation of surface trajectories using currents from the AMSEAS ocean model. The measured radar currents display a clockwise eddy with a tidal currents overlaid on it, while the model is exhibiting a much stronger flow to the west, so there's some improvement to be made in the model. Using these daily runs, we can generate an ensemble of simulations and develop robust statistics on the validation of the model's skill at estimating surface drift. On the left is an animation of daily separation between HFR and AMSEAS surface drifters as a function of release time. The blue lines are the separation of the individual 169 drifters, and the thick black line is the mean. The animation covers from March 9th to April 9th, 2020. The separation after 24 hours starts on the order of 20 kilometers, but grows to 60 kilometers through the course of the month. This animation covered the La Parguera region on the southwest corner of Puerto Rico. So plotting these statistics as a time series reveals the skill of the model from March to July of 2020. This plot shows average model trajectory error after 6 hours in blue, 12 hours in green, and 24 hours in red since the drifter release. The error in the model was large in March, but then reduced and stabilized over the ensuing months. This figure again is for the La Parguera region on the southwest corner of Puerto Rico. The gaps in the time series are due to the gaps in the HF radar coverage, so it didn't allow us to perform a proper validation for the model. Looking at another location where HF radar coverage is available was the western coast of Puerto Rico in the Mona Passage. The trajectory errors were much lower in this region of the model. The tidal currents are strong in this region, and the model is accurately capturing those dynamics. Okay, now on to the topics related to the title of this talk. We're currently presently evaluating new products to integrate into the Sargassum tracker. Firstly, CARICOOS has begun running an instance of the FVCOM model for the Caribbean. This increases the temporal resolution from 3 hours to 1 hour and increases the spatial resolution of the model, especially near the coast, which will hopefully provide better forecasts of sargassum in the coastal zone. So we evaluated the FVCOM model at several instances. This slide shows a 24-hour animation of HF radar surface currents on the left, the existing AMSEAS model in the middle, and the proposed FVCOM model on the right. Both models display a surface drift to the west, while the measured surface currents exhibit surface transport onshore and towards the east. And another example of model simulations show similar differences between the model and the measurements. So the evaluation of the FVCOM model will continue. The previous slides were from an experimental instance of FVCOM in January of 2019. The model began running in real time in early February 2020, and we're going to add this model to the daily validation tool in the near future. So the last item I'd like to discuss for today's talk is a beaching event that took place on May 3rd, 2020. It occurred on the southern coast of Puerto Rico near the Jabos Bay Estuarine Reserve and was documented on Facebook. So you can see the large mats of sargassum impacting the beach. We inspected the alternative floating algae index for April 28th, the nearest day that had the best coverage before the beaching event. The AFII shows higher values near the coast, but it shows the highest values along the north coast of Puerto Rico. So there could possibly be some sargassum offshore of the coast at this time period. We then next examined the maximum chlorophyll index, a product from NOAA, AOML, which exhibits structure of sargassum patches along the south coast of Puerto Rico. So based on the success of the NPI product, we ran trajectories using both the AMSEAS and FVCOM models. Both models displayed a transport to the west, which would agree with the beaching event. The FVCOM model provided higher resolution and better coverage near the coast, especially in the vicinity of the beaches where the sargassum beaching event took place. However, the existing particle model we're using does not properly strand particles on the coast. In order to add that feature, we will utilize the OpenDrift Toolbox, which is a Python software package for modeling the trajectories of objects drifting in the ocean. So in closing, I'd like to review the topics I covered in my talk. The sargassum issue in the Caribbean has been present since 2011 and will be present for the foreseeable future. The AMSEAS model is presently being used to forecast coastal water trajectories and hence sargassum around Puerto Rico and the Virgin Islands. We are evaluating new satellite products from NOAA to estimate sargassum concentrations, and we're also utilizing the FVCOM model for improved current resolution near the coast. Lastly, both the AMSEAS model and the FVCOM model displayed skill in recreating the surface transport that led to the sargassum beaching event that took place on May 3rd, 2020. So thank you for watching my presentation on new products for the Sargassum Tracker, and good luck with the rest of the conference.